Hey guys, and welcome back. So throughout this skill, we have heard this word a few times already, that is the kernel. Now I suppose I really should talk about what exactly is a kernel, because honestly it really isn't quite so obvious. You might have heard this word a few times, but truly, what does it mean? Well, ultimately the kernel is the core of the computer, and ultimately this kernel, this core so to speak, has total control over the entire system's performance. And the thing about the kernel is that it's always on, it's always present. This is how necessary and vital the kernel is. Now when you have a piece of software that has to talk to pieces of hardware, then the kernel is going to be directly involved in this process. So say for example, we had some application that could communicate via the kernel to things like the CPU and the actual disks and the devices. These could be peripherals, as well as the actual memory to handle memory management. So basically, the kernel is the lowest level abstraction layer of the operating system. So earlier on, we talked about the proc folder that was going to handle processes, and we could see all the processes with that ps-e command. Now for these processes, there's going to be some type of requirement to access hardware, the disk, memory, handling interrupts, and ultimately it's going to be the kernel which is actively distributing resources to processes as they need them. And the kernel can ultimately move these processes into the background where they have less priority, and then back into the foreground where they get more priority. The kernel is going to be responsible for controlling all of this, as well as handling those interrupt requests. Now originally, back in the day, computer operating systems, they used to have a built-in and very specific set of attached hardware. Simply put, if this device was not actually built into the kernel itself, it could not be added, could not be used. Now you can imagine as technology progressed, this model was not quite so useful and became very outdated. As such, the kernel had to learn to be a little bit more dynamic, such that we could, for example, just hot plug in a random USB stick and still have it operate. So now, the actual model we use for the kernel is really stripped down, it's minimal, but ultimately it is modular. Simply put, device support is going to be handled by what are called LKMs. These are loadable kernel modules, and this is what it means to say that the kernel has become modular. Basically, the kernel acts in a minimalist way, only loading what is necessary, and as new devices are discovered, such as a USB being plugged in, the kernel is going to begin to load modules as needed to handle these particular devices. So what we want to be able to do is to learn how we can manipulate and work with these kernel modules. So check this out then. Here are some of the core commands that we are going to need. Now the first command we're going to use is something called lsmod. Let's check out the man page, and it tells us the lsmod is going to show us the status of the modules in the Linux kernel. Simply put, it's just going to neatly format whatever is inside the proc modules directory, which we already explored earlier on within this skill. Crucially though, the point is that it's only going to show the modules which the kernel is currently using, what is actually being loaded, because like I say, the kernel is going to be minimal. It's only going to add modules as necessary. We don't just load absolutely everything. Okay, so I'll press Q to quit. So let's actually try this command. We'll say lsmod, and look at this. We can see all of these modules that the kernel is in fact using. And notice if we do lsmod help, there's actually going to be no output. This command is just really a standalone command. It just has one feature and one function, that is to list those kernel modules that have been loaded. Now if we want to get actual information, particular information about a module, we have another command which we can use. Let me show you that one. That one is called modinfo, i.e. it's giving us information about the modules. Let's check out the man page for good practice. As we see here, modinfo extracts information from the Linux kernel modules given on the command line. And this time we can see we actually do have all of these different switches. We can do -V to print the modinfo version. We can do -K to provide information about a kernel other than the running one, we have all of these different options available to us. So what we could do is use lsmod to look at the different modules we have available, say for example IP tables, and we can use mod info and specify the name of that module. So we'll say mod info IP tables, and this has given us very particular information about this specific module that is currently being loaded by the kernel. So we can see the actual full file name, we have the description, IPv4 packet filter, IP tables is ultimately a firewall of types. It says the description is an IPv4 packet filter because IP tables is ultimately about firewalling. Makes sense. We see the license, we see some hashing information, and like we learned from the man page, we have these switches available to us. Say for example, if I do -a or --author, we can just get particular information about that module, such as the author, or the description, or the license. So basically, as opposed to getting all of this information, we can filter this. So what I can say here is mod-a IP tables. We can see the author of IP tables, which is what we saw here. We could do -d to just parse out the description so that we can quickly identify what this loaded module within the kernel is doing. In this case, it's an IPv4 packet filter. Similarly, we can see the license information with -l. It's a GPL license, which is a GNU General Public License. So as we've seen throughout this skill, using things like LSPCI and LSUSB, so on and so forth, many different kernel modules are being used to handle these devices. Now, these actual modules do have dependencies. So if I just do mod info IP tables, we can see this depends shows us the dependency which IP tables uses. It uses x_tables. Now, what if we wanted to have a more manual and hands-on approach to controlling these modules? How on earth would we do this? Because it seems like so much of this is just happening under the hood in the background. Well, if we actually want to make changes so that we can manually load and unload drivers, we also have this command called mod probe. So we'll clear the screen. If I say man mod probe and hit return, tells us here in the description that mod probe intelligently adds or removes a module from the Linux kernel. And if we scroll on down, we can see all of these different options that we have available to us. By pressing space, we can keep going. So if I wanted to unload and effectively remove the IP tables module from the kernel, what I could say here is mod probe, and I could do -r, and then specify the name of the module, which in this case is going to be IP tables. Now watch what happens when I go to hit enter here. It actually gives me an error. It says the operation is not permitted. That is because this requires administrator access to make such a change. So what I'm going to do here is to actually use administrator privileges. Now this is another command that we haven't seen quite just yet, but it's all over the place within Linux. You're going to be using it quite a lot. This is called the sudo command. It's basically when you want to perform an administrative action. So we can do sudo and type the exact same command as we did before, but when we go to enter this command, it's going to ask us for our administrator password. But when we go to do this, it's going to ask us to enter our password, and we need administrator rights in order to do this. So I will type in my password right here and hit enter, and it's saying not found. That is because I did IP table. That should be IP tables. Try that again. And there we go. So now if I do lsmod, IP tables will not actually be loaded into the kernel anymore. We scroll on up. Notice that it's actually gone. It's been manually removed using the mod probe command. Now, if we want to reload this back into the kernel, we can do so quite easily. Again, we're going to need administrator privileges to do such a thing. We'll just say sudo mod probe and just give the name of the module. We don't have to specify anything else. Okay. And notice that once I've actually already put in my sudo password, it's not prompting me to do it every single time. Now if we do lsmod, notice at the very top, IP tables has been added. And what I also want you to notice is that automatically xtables has also been pulled in, because that is a dependency of IP tables. See the way there's some type of intelligence to this? Modprobe knows that when we load in IP tables, it's dependent on xtables. So that must also be loaded. Again, we can see here used by IP tables. And again, just to confirm this, if we do sudo modprobe -r IP tables and we do lsmod now, if you scroll through this output, you won't find IP tables, and also because IP tables is not there, there's no need for X tables to be there either. So we do have some type of intelligence going on here. And to close, what I also want to show you is a very important command called the uname command. If we say man uname, this is going to print system information. Notice though, we have all of these switches, which gives us additional information. So we could say uname-s to get the kernel name, which is Linux. We can say -r to get the kernel release, which is this release. We can say -v to get the kernel version, as well as a whole other host of information. If you want to see absolutely everything, you can say uname-a for all, and that is going to print out absolutely everything. So really try to conceptualize what the kernel does for us. It's a very core component of computing. We need the kernel, but also understand that the kernel has adapted and evolved throughout time. No longer do we have to specify particular built-in modules. Instead, the kernel prefers to be minimal and modular, where modules can be loaded in dynamically as they are needed. And whilst this can happen automatically under the hood, we do have the option to be able to control this process using modprob. And if we're looking for information about the running modules which are being loaded currently, we can use lsmod, and we can find out information about each of those modules using mod info. Okie doke, so that is us for our introduction to the kernel in Linux. I hope this has been informative for you, and I'd like to thank you for viewing.